Okay, so we are in chapter 1, section 2, and I'm going to do this, oops. Yeah, I'm going to do this a little out of order. I'm going to do a complete the square that's a little more challenging, and then I'm going to do a complete the square that's a little less challenging. Um, I have more time here, and I can kind of rush this one a little bit. So sometimes things don't factor very nicely, and this is a technique that you can apply even if stuff does factor. Um, so what you end up doing is you take um, the constant term, move it to the other side of the equal sign. And basically what you do is you create a gap here and you create a gap here. Now, when I do this, before I write in the 1-9, I actually, in my head, think of it as putting a parking lot and putting a parking lot, or two spots that I'm going to fill. And to complete the square, what you do is you take the middle term, the coefficient of the middle term. Really, you're taking the coefficient of the thing that is the half. See, that's 2, that's 1. That was 4, that was 2. That would be 6, that would be 3. You're always taking the one that's of the half. And you take the coefficient, you multiply it by a half. Now, you'll notice that the 2's cancel, so I've got 1/3. And I've got a lot of arrows pointing everywhere, so right now this is the only arrow that is relevant. And this 1/3 gets squared, hence the term completing the square. So 1/3 times 1/3 is 1/9. This is the value that fills in both of the parking lots. Now, in this process, we're going to need this 1/3 again. And it works out that if we were to factor this using the AC method, we would end up with x plus 1/3. What we get after we've taken a half always is right there in our factoring process. So we don't really need to do anything here. We just get the 1/3. We know we square it and put it there and there. And then we actually just drop it in the spot where the factoring would be. Now, it really would read x plus 1/3 times x plus 1/3, but since they're the same base, we square it. Now, 1/3 plus 1/9, well, getting a common denominator, it becomes 3/9 plus 1/9, or 4/9. Now, we're going to use the square root property, and we're going to square root both sides. And when we take the square root of a number, remember that we could have a positive square root or a negative square root. And when we take the square root of a square, we're left with what's in there. Okay? Now, we have x plus 1/3 is equal to plus or minus 2/3. We're going to move the 1/3 over to the other side, and we get 1/3 plus or minus 2/3. So we actually get two problems out of this. We get negative 1/3 minus 2/3, which I wrote right here, and we get negative 1. And then we have negative 1/3 plus 2/3, which leaves us with 1/3. Okay, now we're going to do number 38 in the completing the square process. Now you'll notice that the 13 is already over on the other side. And if you put it on the other side, 13 doesn't have factor pairs. It's a prime number. So you wouldn't be able to apply the AC method. And so what we do is we create our little parking spots. And we do it on both sides of the equation. And we're going to take 1/2 of the middle number, which is negative 3. Now when we square that, negative 3 times negative 3 is positive 9. So you're going to get a positive 9 there and a positive 9 there, which gets us to, oops, I typoed. 13 plus 9 is 22, not 21. And that'll change that there, and that there, and that there, and then there, and then there. Okay, now, here we go. So remember I made this comment earlier that what we get when we have a half automatically just lands right there. Now, if you factored this using the AC method, you'd get x minus 3 times x minus 3, and that becomes x minus 3 squared. All right, so we're going to apply the square root. And remember, this isn't a 21, this is a 22. That's just my typo. And I look at it and I go, okay, I take the square root. Well, 22 doesn't have a nice square root. It's an 11 and a 2, so they're both prime numbers. Nothing's going to pop out of there that multiply to 22. So if I was looking for any values that repeat themselves, there aren't any. So I'm just stuck with the square root of 22, and I have plus or minus there. And then I'm going to add 3 to both sides. So I have 3 plus the square root of 22 and 3 minus the square root of 22. Here's our 3 minus because that's the leftmost one. And here's the 3 plus, and that's the rightmost one. Okay, so hopefully that makes sense. All right. I'm going to do a quadratic videos next.